Hello again. This is the course of data structure and algorithms, and we're going to go to the new chapter, which is doubly linked list. So in this chapter, we are going to learn doubly linked list. We know from the previous chapter, we learn about the singly linked list. So we have single, double. So we call it the doubly linked list. And let's check what we are going to learn on this chapter. And the first this is the slides that I took from the book, okay, and we are going to learn about the concept of doubly linked list. The doubly linked is ADT, we call it ADT. If you remember, this is the abstract data type, and then the doubly linked is in Python, okay, and we are going to learn one kind of examples using the doubly linked list. This is which we call as the positional list. So what is doubly linked list? Doubling link is, you can think it's kind of train, okay, so it's connected one each other, for especially for the for this of the content of the train. And we can think like what we already learned in the singly linked list. In the singly linked list, we have only a single connector, okay, single connector to the other node. But in the doubly linked list, we have another implementation of node list. If you still remember, we have node, okay, and the node, it represents one element, okay, and one of the element, it will connect to the previous and next. So if you check this example, okay, we have the previous. It means I would like to go to the previous, which is the header. So the header is the node to represent, this is the first node, and the trailer, yeah, this is the header, it's represent the first, and this is the trailer, it represent the last node. Okay. And this is only a special node because we want to know which node is in the front and which node is at the end. And if we know that this tiger is in the first node, then it will have a connector to the header. It will have a connector to the next node. The same with this element, we will have a connector to the first node and it will have a connector to the next node. Okay. And the frog is also the same. It will have a connector with the previous and it will have a connector with the last one. So we have previous and we have next, and we know what is the element at the particular node. Well, some implications of the doubly linked list would be the music player. Yeah, if you know in your computer or in your smartphone, you have a music player, so you have next and previous parent. So the kind of application they will use this doubly linked list for sure. And the browser cats which allow you to hit the back forward page. For example, if you are in the web page, okay, when you are doing browsing, you can go forward and you can go backward. So that's also one of the application. And the undo redo functionality. So for example, if you use Microsoft Word or if you use Hangul, so you can undo. Undo means you want to cancel what you already did. Redo, so you want to re-implement what you already did. Okay, so those kind of things are the application using the doubly linked list. If you want to know more about the application, so let's see how can we do the process. Okay, so you can, if you still remember the basic operation in the data structure, there are at least two: insertion and remove. Okay, so in the insertion, we want to insert a new node. Now let's see, I have this doubly linked list. So I have A, B, and C. And let's see that the P is the current node. Okay, I would like to insert. I would like to insert Q, and Q, I would like to insert it in between P, B, and C. Okay, so how can we do this insertion? So in this case, we are going to put one node. So we are going to create a queue. And once we create a queue, first we will remove this one. We will remove the connector. After we remove the connector, then we will put the connector of the Q into the P, and then we will put the connector of the Q, the next connector, into the C. And once we have this one, so we delete this part, we delete this connector, then we will have the Q in between P and C, or we can say this is the new node, which is X. What about deletion? So in the deletion is also have the same idea, okay, because we are doing the deletion, so we can check what is the node that we want to delete. For example, here is P. So the node P here we are going to delete. So we want to check what is the connector of the P. We know that the P, which is this is the element of D, it's connected to the C, and then it is connected to the trailer or the last node. So using this idea, then we want to remove this one first. Okay, so we want to remove this one, want to remove this one. After we remove the connector between the node C and D, then we will add this. Okay, so we want to add the C. The C will be connected to the trailer, and the trailer will be connected to the C. So yeah, the D will be deleted, and then yeah, we have a new doubly linked list, something like this one. So this kind of doubly linked list is important when you have the application like what I already mentioned to you, like the music player or the web browser or something related with the Microsoft Word and etc. So in the doubly linked list, okay, we have the class doubly linked list, and then yeah, you know already about the node. Okay, so we use also the node that we already learned. So in a node, yeah, we can define more attributes like what is the element and what is the next and what is the previous. So here we also, yeah, okay, in the node we have the init. Okay. So in the init we want to put one more. We have two nodes. Okay, we have two special node, which is a header and trailer. And then after we have the header and trailer, we want to put the header with the next. It is the one of the attribute in the node. And then in the trailer, we have an attribute which is previous. So it is related with the previous node. Okay. And then the size, it start from 0. Okay. And yeah, there are the basic method which is length and is empty, and you can see that okay, the insert between and delete node, so those are the two operations and you want to do the operation in the doubly linked list. And the parameters that we can use here is the is the object, and then the predecessor is the previous node, and the successor is the next node. So if we want to insert one node, then we need to give what is the object, what is the element of that node, and then what we will also uh, check this information about the predecessor and the successor. So the predecessor means it is the node in the previous, and the successor is the node in the next. Okay. So the predecessor will be updated, okay, and then the successor also will be updated, and then we will increase the size with 1. Okay. So if this the insertion, yeah, you will do something like this one. If you do the deletion, then yeah, you need to just give the node, and then we want to check what is the predecessor. So the predecessor means the previous one, and the successor is the next one. And then what is the thing that we want to update is, if we want to update the predecessor, then let's update the attribute next of the predecessor. So the next of the predecessor should be the successor, okay, because we want to delete the current node. And in the successor, okay, in the successor, we want to check what is the previous. So the previous should be predecessor, okay, and then the size will be minus by 1, and then the element, which is the node element, it will be deleted. So how can we delete that one? So we will just make the node dot previous, node dot next, and the node dot element becomes none. So none, if you already learned the basic concept of Python, so none it means it is nothing, so there is no value. So if we just put no value into that particular node, then it means it is deleted. So we will return the element to the basic the structure. So you can check this in the okay, if you check this on the Python, okay, so I give you the code here, okay, doubly linked list. So this is the node, and then yeah, you I guess you already see on the PPT. So in the node class, we have the element, and we will include one more attribute, which is previous, and we have next. So if we have only next, then it means a singly linked list. Because we have two, which is previous and next, so we call it doubly linked list. Then after we have the initial or the constructor for node, we want to have the constructor for the doubly linked list. So we have the header, header next, trailer previous, and the size. So this is the same with what I explained before. So if you run this one, of course, this is only the ADD. There is no implementation. You need to make your own implementation for this one. Now, what about the performance? So we, of course, when you do the data structure, and if you build your own data structure, you need to know the performance. So the performance in the doubly linked list, if you use the space, of course, the space is n. So it depends on the number of elements in your doubly linked list. And I can say for the space, you can have on. What about the doubly linked list for each position? For the each position is just take only one. Okay, so in one element or in one node there will be only one. So we can just say this is O1. What about the standard operation? The standard operation like the insertion and the removal. The insertion takes O1 time, because once you insert a particular element, then it will just connect to the previous and the next, and it will not ruin all the structures. Okay, so you don't need to search all the structures. You just need to build. You just need to insert one node, and you just go to the previous and the next. So it's just O1. And also the deletion, the removal, you already see the code, that it also connect to the previous and the next, and then it will delete the connector, and then after we have the new one, then it will be removed. So that's also one. So the performance is quite good with the doubly linked list. So that's why there are many other kind of lists that can be implemented with the doubly linked list. So to provide a general abstraction of a sequence of elements with the ability to identify the location of an element, so we define a positional list. That is a positional list. So the positional list, it means I have a position arc or a position marker. Okay? So the position, it means it will act as a marker or a token. So this marker will determine what you want to do with that particular token, or what you want to do with the particular, it's not index, okay? So we call it marker or token, okay? And it is a marker or token within the broader position list. The position P is unaffected by changes elsewhere in a list. The only way in which a position becomes invalid is if an explicit command is issued to delete it. So we will check later. So there are some methods inside of the positioners. For example, if I want to know the element, then we can just P. So P, it means the position in a particular element, and I want to check the element. So it is the element. So for example, in the previous doubly linked list, we have tiger. Okay, so if we just P that element, then it will return tiger. Okay, so this kind of method, I think, is also the same when you build your class in the Python. So there are some other operations in the positional list. For example, first. Yeah, so first it means I want to know the first element of the list, and then last I want to know the last element of the list. Before P, so I want to know what is the element before the position P, and I want to know what is the after P. Then I want to know what is the element in the position after P. Okay. So we have also is empty. Okay, we already know this is empty is the list that it returns true if the list has no element. And the length, it means I want to know how many elements in the list. And then the iter, it means I want to check the I want to do the iteration for all the elements. And you want to add first. The add first means I want to add a new element in the front. Okay, and then I want to add last is also the same. I think using this statement, we know that we want to add a new element at the last part, okay, at the end of the list. So we can also do add before, PE. So I want to insert a new element before position P. Okay, so the P is a position and E is the new element. Or I can also do with the add after. For example, I want to add a new element E, and then I want to add it after the position P. Okay, so all the things here is related with the position. And I can also do with the replace. For example, I want to remove. Okay, so I want to remove a position P. Okay, and I want to remove the element at position P. So the element E will be removed and it will return the position, the element formally at position P. So we can also do the deletion. So the deletion means I just want to delete the particular position P. Okay, so we can see this is one of the example. Okay, so let's see. If I have the L, so the first L is at last 8. Okay, it means in this case I have the P, and then I will do the Q, and then I will have R, and I will have S. Okay, so those are the what I call. So this is the position. Okay, so I already determined the position as P, Q, R, and S. So it will be a sequence. After P, it will be Q. After Q, it will be R. After R, it will be S. Okay, so yeah, this table shows a series of operation of an initially empty positional list, and in order to identify position, the variables such as P and Q are applied. So yeah, as I mentioned to you, I use the P, Q, R, S. In other cases, you can use like A, B, C, D, or you can also use another alphabet like for example, E, F, G, H, that's yeah, your definition. But in my example, I just use this P, Q, R, S to explain this kind of positional list. So for each exposition, the list contents are displayed with subscript notation to denote its position. So the subscript, okay, the subscript is this one, okay, P, okay. Now let's see one by one. If we are adding the last, what is at last? So we are going to add one element at the last position. So this is the object name E8. Okay, so I would like to add the element 8 in the last position, and the last position is P. And then I want to know what is the first one. So what is first? Because we have only one element, then this is the first. But the return value is not the element, but we want to return the position. So the position in this case is the P. Yeah. And what is the next? I want to add after. So let's put after P, and the element will be 5. So because I have used the P, okay, I have used this P, so the next element that I will use is Q. So I will put the element 5. This is the element 5. And I want to put the Q as the position of the element 5. Okay. So I will already use the Q here. And then I have 5Q. So 8P, it will be the first element, and 5Q will be the last element. Now I want to check what is before Q. Okay, what is before Q? So before Q is P. So it will return only the position. And then after I do the before, I want to check add before. Okay, if I want to add before, it means I want to check what is the current position. Now I want to check the current position is Q, and I want to add 3. Then what is q? Okay, I have this q. Okay, I want to add p4, so it means it is here. Then 3 will be added here, and then of course I already used p and q, then the next position will be r. So it will return r, and the new will be p8, p3, r, and 5q. Okay, and then after we have this, now I would like to check the r. What is r? R is the position. Okay, and I want to know what is the element of r, then I will get the return value, which is 3. And then I would like to I wanted to check what is the after. Okay, so in the list, I would like to check after p. So after p, you can see here p. Yeah. So after p is the r. Okay, then it will return the position value, which is r. I want to check what is before p. Okay, before p, yeah, you can see here p is the first element, so there is nothing before p. If you still remember, in the Doubly Linked List, we have two special nodes, which is header and trailer. Before p, because it is nothing, so it is the header. Then it will return none. So there is no position. There is no such index or such variable like p, q, r, s. Now I would like to add the first. Okay, so I would like to add the first, and I would like to put the element 9. What is at first? So I would like to give the new element 9, and 9 will be in the first part of the list. So we know that the first is 8, and then now I'm going to add one more element, which is 9. And we already use p, q, r, s, so the s will be added here. So now I have a new position, which is S, and the position of S is in the first of the list. And after I have the S here, then it will be returning the value, which is S. So this is the new one, 9S, 8P, 3R, and 5Q. Now, if I want to delete, what happened with the delete? So I can delete at a particular element. Let's say I want to delete the last one. So the last one will be the Q according to this kind of element. So this Q, it means the value is 5. So I would like to remove the element 5. And after I remove the last one, then I have 9S, 8P, and 3R. So the last one will be replace. Okay, so what is replace? So the replace, as I mentioned to you before, okay, so there are two. Okay, replace and delete. If we want to replace, it means we want to replace the element E at the particular position P. Delete means I just want to delete the position P. Okay, so here I have the position P and then 7. Okay, so what is 7? Okay. Oh, so 7 is the new element, yeah, and then I want to replace the 8, yeah, because in the position P, the first element is the element name is 8, and I want to replace 8 with the new element, which is 7. So now the new element now becomes 7, and we want to return the value, which is the previous element, which is 8. Yeah, so using this kind of positional list, we can apply some other things, like, yeah, if you want to for example, if you have music player and then you want to insert a music in between some other music, and then if you want to shuffle, and then there will be a new structure, and then you can know what is the next music and what is the previous music. And then if you want to change the music in the particular location, then you can use replace. Or if you want to delete some particular music in your music player list, then you can also delete that one. So those kind of things you can use with the positional list, with the basic of the doubly linked list abstracted structure. So this is the positional list. I guess it is almost the same with the doubly linked list, because it used the basic doubly linked list. You can remember, if you remember about the object oriented, this is the inheritance. So it inherits from the superclass. And then we have the class position. So the class position means I want to check I want to create the position of a particular element. So in the position, it contains the container and node. So what is container? So container is one node, and it consists of the position. What is the position? You can have like P, Q, R, S, like that one. And the node, it represents the node, you know, the previous and the, you know, the next. And yeah, we have the element, which is the node element, and then we have the EQ. It means I want to check whether it equals or not, and not equal. So NE is not equal. And then we can check the validation. Okay, so the validation is just to check whether the position is still that in that position or not. Okay, and then we want to make the position. Okay, and then as I explained to you, we have the first, and then we have the last, and then we have before, and then we have after. And then while we are doing for each of the element, we can do the iteration. Okay, and then we can insert between, and we can add first, you can add last, you can add before. Okay, we can do the add after, we can delete, and we can replace. So all of those things, yeah, you can see here. If you want to add first, then you will use the insert between. The insert between will be used, and the parameter will be different. So all of those related with the insert between. The only difference is only the parameter. Add before, also you use the insert between. The only difference is the parameter. And also the add after, it use also insert between. The difference is the parameter. How about delete? So when you use delete, so you can just delete the particular node. And then when you do replace, it means you want to replace the some kind of element in the particular position P. Yeah. So if you want to check on the Jupyter Notebook, in the Jupyter Notebook file, I already include the position list. So this is the abstract data type for the position list. I guess it is the same with what I explained in the PPT. Yeah, so if you want to use this one as the one of the application in your project, yeah, that also will be good. Okay, I think that's all about the Doubly Linked List. I will continue the next chapter with the other video. So thank you very much for listening.